Okay, so you should be in your seat. Is that better? Yeah. Y'all are a little cramped, sorry. Okay, we're still sorting out the seating chart. Thank you for asking politely for adjustments if your seat was a little cramped. We should be okay now. So this is where I want you, when you come into class tomorrow, but I'll kind of continue to mix up our seating chart so that we have like different people to work with and stuff in case like this time you love your seat, but next, like, person next to you maybe hates it, so next time maybe they'll love it and you'll hate it, and it'll all be even. So we've got all this. What you need to know now, while I take attendance, is your new notes can be found in the red folder. Remember, Monday is the day we get like all of our papers for the week. So this packet is like nice and thick because we're going to use it starting today all the way through Friday. So you need to keep track of it. If your folder is out of papers, there's my extra folder. If your folder is out of papers, then you're already doing a great job of like sorting it out and finding folders at other tables.
Yep.
Got a table? Okay. Thank you. While I'm taking attendance, I want you to take a look at this do first. One example of finding the domain restriction of a function, which is probably what you found to be the most difficult on your problem set over the weekend. It was that back page.
Yeah.
So that's why I want to talk about it and answer some questions. This example is very, very similar to the one that we did on Friday. So what you can do is between you and your neighbors and your notes, you should be able to get started with this one. Like someone should have enough in their notes to kind of get figured out. Notice that the page number on your notes, look down at the front page, what's page number? Because this is just a continuation of like page 15 that we left off with on Friday. You want to be like taking the staples out and collecting this almost like a pre-cal book in your binder. The lesson right before this should be able to help you out on this, and so you can grab those notes from Friday and see an example. Because if not, it's going to be like blank mind, I'm not sure what to do. Okay? Using your notes, using your neighbors, see if you can figure something out while I'm taking attendance. And we'll get started. Go. Using your neighbors, using your notes. Marissa, Cristobal,
Here.
Jose, Jose,
Here.
oh thank you, Edlin, here, Hillary, here, Jeannie, here, Alondra, here. Brian, here. Jason, here. Juan, here. Timothy, here. Brenda, here. Mon, here. Joshua, here. Jesus, here. Samantha, here. Leslie, here. Isaiah, here. Jenny, Jenny? Still not here. Jane Nguyen? Jimmy? Here. Karen? Here. Corman? Here. Maggie? Here. Adrian? Yeah. Joanna? Here. Isaac? Here. Leo? Here. Cleo? Here. Diamond? Here. Luis? Here. Justin? Here. Okay, thank you very much. So look at your example from at the bottom equal to 0. Very good. Use your notes. Use your people around you. Good. Perfect. But here it's off on the side. You're like, it's exactly the same. Okay. Do you have your notes from like the day before or even? Okay. So whenever you're absent, we can either 1, watch video to get caught up a little bit using the notes you already have, or 2, find the time now to arrange with me to get caught up on that. I mean, I'll go over the do first a little bit, but it might be a little overwhelming, missing it, okay? But I won't have time to like catch you up right now, okay? Not right now. Next time you need to bring it, we're about to start, and then I'll just follow with us. But next time you either ask me a little bit sooner or bring it with me. Yeah, well, you're plugging the 12 into this. Okay. Yes, wonderful. Yes, perfect. Okay. Welcome back. Voice is off. Thank you. Cool. Thanks. Happy Monday. How's the weekend?
Stressful.
Stressful? Why is it stressful?
Because I have my brother back to college.
Family members going off to college. College people are finally leaving town if they're going somewhere.
But it's going to be chaos.
Anyone else? Any workers out there work this weekend? I think we talked about this. Where do you work again? Home Depot. Nice. So when I'm fixing stuff at my house, can I ask you for help? Do you know much about the Home Depot stuff, or you just sell it? What do you do while you're there? Like, what's your Home Depot role? Cashier.
Okay.
Did I tell you all where I worked in high school? Give it a guess. Close?
Burger King.
Nope. Wendy's. I worked at Wendy's, good old days, and I was drive-through. Hi, welcome to Wendy's. Can I take your order?
Were you the driver lady that only gets one sauce when they order a chicken nugget?
For real, yeah.
Oh no, I was generous.
I hate that.
How many
Give me
you
one
want?
sauce
No,
at a
I
time.
don't It was stressful. Lunch roll? Okay, let's bring it back though.
That's what one.
Okay, thank you very much. So, we are going to jump in to hopefully go over another example of domain restrictions to help us to feel a little bit better about this, okay? And then I promise I will answer all your questions in a second about what to do with your problem set and announcements, reminders of things to come, and then we'll get started with the lesson, okay? So we've got a function here, and we talked about on Friday how quadratics had a domain of negative infinity to infinity, but for the first time we started seeing some functions where there were certain x values, or in this case c values, where our function would be like undefined or there was some sort of issue going on. And there were two main things that we needed to watch out for that could cause our function to be undefined. Anyone remember the two issues we might run into? Isaac?
Do I say both of them or?
Whatever, if you remember both, say both.
Oh, okay, so it can't be divided by 0, and it can't be the square root, or, yeah, the square root of a negative number.
Lovely. Notice my poster if you need to remember those two things. These are two things that will give us some issues, and so we need to figure out, in this case, if there are any c values, which there will be, that are going to give us one or both of those issues. In this case, we're dealing with only one of those issues. Can anyone tell me what we need to watch out for with this function? Is it dividing by 0, or is it the square root of a negative? Which one might we have an issue with? Maggie?
Dividing by 0.
Dividing by 0. We do not have any square roots here, so we can have negatives all we want. Negatives on top, negatives on the bottom, we don't care. negatives are only an issue when we're trying to take the square root of a negative. That's not a real number, okay? What we're dealing with here is a denominator that we have to watch out for when that denominator is equal to 0. So you are on the hunt. First task is to figure out where that happens. So what you probably noticed, I saw a lot of people doing this from their notes from Friday. Our starting point is to set that equal to 0 to try to figure out where that happens, okay? Luckily, this example was pretty similar to the one we saw, so if we couldn't remember how to factor, hopefully you were able to use the example to figure it out. Jesus, how do we factor this? You could totally use your box, and you'd say like c squared, and the thing would be weird because you have 0 down here, but you can totally do it, and I've seen the people that do it. Anyone else remember what another quick way I said you could do it on Friday? Come on. Since c is a common factor, we can basically like factor it out, kind of like the opposite of the distributive property, right? Cool. Whichever way makes sense to you, do it. Okay? Then we've got it factored, which means to make this equal to 0, the 0 property states, can't talk, that one of these things has to be 0, right? Which means we have two possible c values making this equal to 0. First one would be 0 itself. Then you'd have 0 times 2, and that would cancel out to 0, right? Second one, what value c would make this equal to 0? You just shout it out. Negative 2 plus 2 is 0, that would cancel that out. Do you need some of Ms. Frisbee in particular? Oh, got it? Maggie? Cool. Alright, so these are the two values. These are not like my answer quite yet, but I'm just like highlighting them right here. That box is like, these are the two numbers that give us problems, right? Because it didn't ask us to just solve. It asked us to figure out what our domain would be of this function. Did I use the c plus 3?
What?
Did I use the c plus 3 up top? No. Literally, it could have anything up there because the top is not going to give us any issues. We can plug things in up there unless there was like a square root up there, and then we would have had to worry about a negative underneath. Okay, so all the other stuff we're not worried about. We were just examining the new denominator because we didn't want it to be 0. Okay? Yep.
Can you explain how you got the 2 at the same time?
Yeah. So from this being factored, if I have something times something equal to 0, one of these somethings must be 0 to make the whole thing 0, right? So if this something, here's my underlined pieces, if this something is 0, then you would have 0 times 0 plus, 2, which is 0 times 2. That's going to give us 0. So c could be 0. If this something was 0, c would be negative 2, right? Because then you'd have negative 2 times negative 2 plus 2, and this would cancel out to 0, and we'd have 0. Okay? So those are the two the two solutions to that equation, which mean the two places that we have issues, we have 0 on the bottom. We don't want 0 on the bottom. Okay? So now we want to write a domain for all real numbers, except for we want to leave out 0, and we want to leave out negative 2, right? So that means we got to start all the way over at negative infinity. All those numbers are good. They're good. They're good. They're giving us positives or negatives. I don't know. We can figure it out. But they're giving us positives or negatives. But they're not 0. They're not 0 all the way until negative 2. Remember, this has to go in order. So I have to go from least to greatest. Okay? Why did I put a parenthesis right there for negative 2? Diamond? Yeah, go for it. Just because I've heard from you, Maggie. Stops at negative 2, and do I want to include negative 2? No. Bracket would be include negative 2, but we want to throw negative 2 out because it gives us 0 on the bottom. Okay? Then we keep going, because between negative 2 and 0, all those numbers are good. If you plug in like negative 1 or something to this equation, you're going to get a number. You're not going to get 0. Okay? So you go union negative 2 to 0. All those numbers, we're good to go. I don't care what they equal, but they equal something, some random number. Okay, and then I stopped at 0 with a parenthesis because 0 I can't include because it would give me 0 on the bottom, right? Okay. Then there's also numbers past 0, right? Because we said everything except for these two. So I gotta say union not including 0, but just past it, 0.1, 0.2, all the way on forever to infinity, I'm good again. Okay? Yep. Oh, move. That's what she says. Move out of the way. Okay? Now, depending on different cases, like, you might not want all real numbers except for one number. Like, quick note, if this was our function, okay, we're not worried about 0, now we're worried about what type of numbers. Let's see, Adrian, in this type of problem, we're not worried about 0 on the bottom because there's no division. What type of numbers are we worried about?
The square root.
Of what type of number? Of negative numbers, because those would be not real numbers, right? So we're going to still take this information underneath the square root and set it equal to 0, because that's where it changes from negative to positive. So we're still going to use 0, but we're not worried about 0, we're worried about negatives, right? So I'm going to add over the 4 as a quick side note just about like other examples that we went over. And I'm going to put it on a number line because I've got to figure out, it's not like, oh, just throw out 4. Like 4 is okay. What we're worried about is where the negatives are. We got to figure out whether the negatives are on this side or this side. Okay? So let's think about this side. If you have like 0 or 1 or 2 or any of the numbers over here, and you plug them in right here, are you going to get a positive or a negative? Tim, if I plug in 0, am I going to have a positive or a negative underneath the square root? 0 minus 4. Positive or negative? Negative. So all these numbers are bad. Negative 1, or sorry, positive 1 minus 4, that's going to be negative 2, right? All of those are going to be negative, 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 negative. Starting at 4, we're big enough. So 5, 6, do you see how when we subtract those, they're going to be positive now? So all these numbers are going to be good. So we're going to just say from 4 to infinity, and then let's talk about 4. Over here we use parentheses because we didn't want to include negative 2 or 0, because they gave us 0 on the bottom. 4 also gives us 0, but is it on the bottom of anything? No, so we're fine. We can have 0 in this case because it's not a denominator, right? It's just a square root of 0. So we're going to put a bracket because 0 is fine. We just want to kick out the negatives. Okay? So you got to kind of like figure out where your numbers are that you don't want and then write an interval using the number you solve for. Okay? Okay. So, hopefully, we feel a little bit better about domains, but we will see domains all year long. So we're just going to keep practicing this. You gotta learn to kind of feel uncomfortable. Might not feel 100% yet, but I just keep rolling the skills and we just keep moving because we got more stuff we gotta learn. Okay? Alright. From that, few announcements, business to take care of. It's Monday, we got lots of papers and business. First up, where's my clicker? You don't see it? Yes, thank you. I need Noel's help. Okay. First thing, your problem set is due today. So, if you have it ready to go, I'm going to pass around my inbox. Note that part of it is completion. Did you put a good effort forth, your best on every problem? And then part of it, I'm going to pick problems for accuracy. Also know that I'm not like this crazy lady that I'm going to try to pick the hardest problems to grade for accuracy and be like, haha, got you, everyone's wrong. So know that I'm going to pick problems that I feel like were realistic, and then I also included more challenging problems to kind of like push us to continue to see what we can do with those, okay? So I'm going to pass this around, turn it in. If you don't turn it in to me right now, you technically have until 4:10 like the rest of the people. And I've got this box or a box next door by my desk. You can drop it in, okay? Pass those around. While I'm passing that around, keep your voices off, and I'm going to talk about your next problem set. Round 2, week number 2. So in the blue folder on your table, you should have a blue folder there. If you haven't already, go ahead and grab out of the blue folder problem set 2 for me, and take a look at that. Yep, it has like this due date on the top. Okay, you got it? You got it? Alright. Yeah, if your table's missing them, Sorry, thank you for getting up and walking and checking. One of these days I'm gonna get y'all some folders, but you only have to do this on Monday. So, my bad. Any extras out here so we can help out people walking around looking for extras? 8th period is tough because papers start being empty. Okay. Voices off while those people are sorting things out, and I'm going to talk about problem set 2. Alright? Perfect. Problem set 2 is due next Monday. Okay? As of class today, you should be able to do this first section until the bottom problem, that's the beginning of tomorrow. So one little section, 2 problems, you should be able to knock out, like honestly in like 7 minutes tonight and be done with it. So I suggest trying to keep up this week with, well, I don't need your notes though. Oh my gosh, all your stuff. I don't want this stuff. It's dangerous. Adrian just turned in like everything except for the problem set, but all these things that I don't need. Okay. Any questions about this being due on Monday, just in terms of logistics? Okay, you've got all week to ask me questions, so like I said, keep on pace, and you shouldn't have any issues. Moving on. Today is day 1 of where our goal was for us to be having everything in class, okay? So first up, I'm going to check our calculator situation, and those of you that talk to me, I'm still going to write your name down just to check and like reconcile who's told me they weren't going to have their calculator and all that. So I'm going to do a quick check and just make sure that you have your TI Inspire calculator as I walk around. And then in general, by now you should also have a pre-cal binder or folder. So calculator, 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 calculator. Diamond. Cool. Okay, stay here, but calculator, calculator. Show me, Luis. Paper calculator. Calculator, Maggie. Calculator, calculator. Calculator, 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 calculator. Calculator, calculator, calculator. Remind me your name. Leo. Yes. Down that side. Okay. And we're back. Conversations come to a close. So, with your calculator thing, I am not upset with you. There is no consequence. I'm just writing down your name for now. We will see how this goes in terms of if this continues to be like a pattern for individuals not having it. But in general, like today we're going to use it a lot through the lesson. So you're going to have to look on with a neighbor and like write down as much as you can so that when you have yours, you'll know what to do. But you're going to need it in class a lot, and if you don't have it, it's just hard to keep up, and it's already kind of a hard class, right? So make sure you have it and are therefore prepared for what we're going to be doing. Also, you'll notice you're getting a lot of papers starting to accumulate, and you'll probably notice too, especially in the new first, we're flipping back a lot, and it probably on your problem set to look at examples we've done. So make sure you have your binder folder so that you are putting all of this stuff in one place, keeping track of it. And then like after a unit, we'll talk about like what to do with your stuff if you need to like clear out your folder unit at a time. Okay, last business item. It's time to start tracking participation for your participation grade. So last folder to find something from, and again for those of you with folders that have run out, I'm sorry, last time. In the yellow folder, there should be a pre-cal participation tracker. Grab one. Any tables with extras, if you can just hold them in the air, your folder, so that those people can quickly run to your table to grab them. That would be great. 10 seconds. 5, 4, 3. Voices back off. We're still up here. 2. And 1. All right, thank you for running to get those extras from tables that were missing them. Your participation tracker looks like this. First thing I need you to do is write your name on top. That's very important. Write your name on the top of your tracker because this tracker is very important. And write that it is period 8 on that so that you have it. At the end of A1, I will make it very clear as this day approaches, but for now just think of it as the end of A1. you will turn this into me, and however many stamps you've accumulated will be your participation grade. Therefore, this is like the only paper in pre-cal. I'm usually very nice about like all my extras. I put all my extras right here. They're in the other room. You can get extra problem sets if you lose one. But this tracker, I'm only giving you one of per grading cycle. So the one you just put your name on is the one that needs to be turned into me. If you don't have it to turn in, I'm automatically going to give you 5.5 now. Help you out a little bit, but not that much. You're going to have 5.5 for your participation if you don't have one to turn into me. So first, keep track of it. Second, be encouraged to share either a question, a comment, a shared solution, right or wrong. As long as you are contributing, I will give you a stamp right here for making the effort and like being a part of class, so I'm not just like talking to a bunch of faces that are just staring at me. Then it's like more interactive, right? And it just makes class go a lot better, and it should feel safe. So as long as you're contributing something, I'll give you plenty of stamps. And this is nice because on a quiz or test, I can't like change your score. It's just what you know is kind of what you get, and we're going to prepare you for that ahead of time. But like if it just doesn't go well on a quiz or test, it's hard for me to help you. But on this, like technically we could all get 10s in here, and I'd love for that to happen. And I'll take care of y'all as long as you're putting forth the effort, okay? So this should be a cushion for your grade, not something that hurts you. That's the goal, okay? All right, so let's start off with participation. We're going to be talking about piecewise functions. So very safe question here. If you take a look in your notes, it says a function, I'm not going to read that quite yet, but a function blah, 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 blah is called a piecewise function. So this is an example of a piecewise function and its graph. This is a piecewise function and its graph. All I want you to do first is just kind of get the conversation started with a very safe question that doesn't even have a right or wrong answer. What do you notice in general about this thing that we're calling a piecewise function? Observations. What do you see? Jimmy?
There are different types of equations and on the graph.
Okay, there are different types of equations within our piecewise function. Should we call on someone else? You get to pick.
Oh, I got it. Okay.
Who's it going to be?
Isaiah.
Isaiah, what else?
Also what I noticed is that like it can be lines or line segments.
So when he's looking at the graph part, he notices that it's kind of like a line, and then over here it jumps up and it's like a line, and then jumps down here and it's like a line, and these ones are disconnected. This one over here seems to be kind of connected. Interesting, Isaac?
It seems like the left has like what the function actually is, and then on the right is for what x values that function is applied to.
Okay, so we have almost like I think Jimmy said like multiple parts or pieces of our functions. What we call it a piecewise is it's broken into separate pieces, like Isaac said, for different x portions of our graph. Okay, so for this one, when x is less than 0, smaller than 0, that's over here, notice our graph is just -4, -4, -4, -4, -4. Then, from 0 to 5, it's x, the graph of x. And then, from 5 to infinity, greater than 5, it's this negative slope line, negative x plus 3. Okay, so they're all pieced together into one piecewise function, but it's kind of like having 3 separate functions all together. Okay, you'll see in a little bit, we'll do an example with like a real world application where we're talking about people's incomes and how much they pay in taxes. Okay, so the different groups are different incomes. So from $0 to a certain amount, they're going to have one function telling them how many taxes they have to pay. And then when we get to a different like group or class of incomes, it's going to be a different function, which makes sense because typically, like, you can like talk politics and debate, and that's why this is kind of interesting. But typically, depending on how your income increases, determines how much more you pay, right? Yeah? And so these types of functions you'll see in a second when we talk about income and tax could be the type of thing that are like debated in politics in terms of the actual math behind how much you end up paying with how much you end up making. Okay? So those are the types of reasons you might like want to split it up into separate pieces. Cool? Alright, so let's take a look at a piecewise model problem 1 right here at the bottom and see how we would evaluate a piecewise at different points. So you saw on Friday we had things like this that were like f of a number, and we just kind of said we plug it in, right? But I'm confused, so I need your help, participation. If I have 0 to plug in, I don't know which of these 3 to plug in because there's 3 of them. Usually we just had 1 of them, so I'm kind of confused. So I'm going to give you a second to chat with your neighbor. See if you think you're going to plug it in the first one, the second one, or the third one, and why. And then come back with lots of hands, and I will give someone a stamp for sharing out. Talk about it. Which one do you think? You got it? Question?
Oh, it's
Oh, question's gone. That's how I got it.
all my
You got it? First, second, third? You got your idea? 5 seconds, 5, 4, 3, hands, 2, 1. Hands for a thought, first, second, third, and why? Yes, sir?
It would be the first one since 0 is less than 3.
So this is what type of value, x or y? X. So he says, since this is for x less than 3 and 0 is less than 3, we know we're talking about this piece of the piecewise. So we're going to plug it into that one. You're absolutely right. Other groups, is that what we said? Okay, cool. Very intuitive. Plug it in. Bada bing, bada boom. You should get 3. So f of 0 is 3 because we knew to plug it into the first one. So just one kind of like extra step compared to what we did on Friday with the piecewise, because you got to identify which one. Okay, let's do one more to make sure we feel totally great, and then we'll move on. So I'm on to this one. I'm like, oh yeah, thanks. Now I know how to do this. And I look at it, and I see x is 3, but what? I see 3 here, and I see 3 here, so I'm confused again. 1 or 2, and why? Really quick, talk to your neighbors again. Which one? 1 or 2, because I see 3 in both of them. And figure out which one. 5, 4, 3, 2, 1. Okay, hands. Which one? Carmen? No, Carmen. Remind me your name? Olvera. I know your last name because I know your sisters. Karen. Oh, so close. Okay, eyes on Karen. Karen, is it the first one or the second one?
The second one.
The second one. How do you know?
Because the sign says less than or equal to.
Cool. So this one is smaller and up to 3, but not including 3. 3 is our cutoff point, and we don't include 3. So we're going to use the second one. So we're going to say negative 3 cubed. Notice that negative is on the outside. It won't matter with cube, but you have to be careful if that was something squared, whether it was on the inside or outside. 3 times 3 times 3. So we're going to end up with 27, so negative 27. Happy? Alright, 4 of them. Go ahead. Try these out with your neighbors. Figure out which one. Plug it in. I'm going to give you 3 minutes for 4 problems.
Hold up.
Yes, you're welcome to repeat them. They won't all be the same one. It'll come from
That would be the last one. Yeah, what else? Come on.
Yes, sir. Not there? Okay. So this is 5. This is an x value, right? So like, for example, if this was our graph, 5 would be right here, right? See how it's part of this line, which is only this piece or this portion of our piecewise. We don't care about this or this one. So we have to figure out which part of our piecewise is it coming from and then plug it in. So if this is 5, is 5 smaller than 3, between 3 and 8, or bigger than 8? Where's 5? Between 3 and 8. So you're going to plug 5 into this. You're going to say negative 5 cubed. And so If it was like 40, it'd be bigger than 8, so you plug in 45. Okay. Lovely.
Told you right. The solution. First.
Yeah, so you can label just one, say f of -5 equals and f of. Y'all finished the one we just did though already? You got all those answers down there? And we do these first? Nah, these first, then that. But you are welcome if you finish them, then to go over. Okay? But sometimes I'll choose like special cases that like I didn't have enough like over there, and so I want you to do all the ones practice, and then you go over them.
So you get three, the kind of starts over, like you have three sets. Okay, so you put that back here.
So you're gonna plug it into the second one. Kinda, I mean it won't necessarily go in order, so every time you've gotta re-ask yourself which of these groups am I in. Okay? Cool. Got them? Get them, got them done? I do. Let's see. I had it in one class, assuming I got it back, which I did. No, it's not.
Maybe focus. I'm focused. I got -125.
I guess we're gonna use the first one.
Down to the very bottom.
¿Cuál es el problema?
Okay, here we go. My clock says 10 more seconds, so I'm gonna go ahead and stop it and bring it back. I think those people are there. Okay, here's what I need from y'all. I am going to pick a popsicle stick, and you are going to, I don't even care for right now about the number, I'll just show you on here, and you can check it. I want you to tell me 1, 2, or 3. Like, did I use the first one, the second one, or the third one, so we can check that, and then I'll show you the number you should have gotten if you use that. Okay? So starting with f of 5. That's not this class. Is this this class? Is this one? Yep, there it is. Diamond. Starting with f of 5.
I never do something.
Which one did you plug that into? The first one, the second one, or the third one? Good, and if you did that, she's correct, you would get -125, assuming you did your math correctly. I literally already forgot which one I did. This one. Okay, next up. Joanna? Is that this one? Yeah. Okay. Yes, I see it. I see them all. Joanna, f of 8, which one did you plug that into? First, second, or third? Second, and you would have gotten -512 after doing that math. Next one, Jenny is not here. We don't know if she is. Jeannie, f of 10, what did you plug that into?
The third one?
Gotta learn these new seats. The third one, correct, and that would be 301. Last one, to make sure we feel good to go, Maritza, what did you plug in -5 to? The first one, because it's less than 3, and that should give you 23. Boom. Give yourself a smiley face if you got all of them. Piecewise functions make us happy. Moving on. Flip the page. Alright. Flip to the top of the next page. I am now going to model for you how to graph these on your calculator. For example, this pretty picture I made when I graphed this function. We are going to use this word problem about taxes that I talked about as our example. If you are a person that doesn't have a calculator, or even if you do and you want to take notes, notice at the bottom of the page, you'll see this section. It just has a blank space for notes. This is where you could be writing like, oh, Miss Cott pressed like this button to get to the piecewise template. Like write some notes to yourself in case you think you're going to forget later where to go on your calculator. Okay? Cool. Okay, let's just go super quick.
Jeannie.
Let's see. Jeannie.
Hillary, Alondra, Lon, and Karen.
Does it matter which one's which?
Nope, no, okay.
Who did I miss? Sorry. Who heard their name? Okay.
Jeannie, Hillary, Alondra, Lon, and Karen.
Alright, no problem. So, take a look right here. We got 9 minutes to do this problem. It says right here, federal income tax for a person filing single in the United States in a recent year can be modeled using the following functions where X represents income and T of X represents our total tax, both measured in dollars, like I mentioned. So if you make between 0 and $7,285, 0.10 times X, which is 10% of X, your salary, is going to be how they determine how much you are going to have to pay in taxes. Okay? So for A, we could do this by hand, which I already saw some people jumping on in, but I'm going to show you a trick on the calculator. You could do this still by hand, T of 7,000. Let's figure out which of them we would be applied to. And Lynn, take a look really quickly. If it's 7,000, would we look at the first one, the second one, or the third one? If 7,000 was our income, our X. The first one, because it's smaller than 7,285. So we would literally just do 0.10 times 7,000 and get 700. It just moves your decimal over once when you multiply times 0.10. You can do it on your calculator. So that one's pretty easy actually to do by hand, right? But you'll probably notice these ones get a little crazier, okay? And so I'm going to teach you a tool on your calculator for how to type in a piecewise and use it really quickly to evaluate a bunch of different points. Okay? So grab your calculators, keep this page in front of you because I'm going to cancel out and pull up my calculator guy and you guys just look on with the problem on your paper. Alright. Can we see this? Maybe. It's kind of small. So just do your best. Alright. If you go to your scratch pad by using the little like moving calculator over here, you can toggle between a calculator page and a graph page, right? Go to the graph page, and if you need to press tab like me, it'll bring you to where you can enter F1, F2, all that stuff. Okay? I want you to go up to F1 if you already have something entered in it, like me, from the previous class. You can go ahead and delete it, because I want all of us, if we can, to type the function into F1 so we're all talking about the same thing. Because I'm going to call it F1 later, and if you call it F1 and yours is actually F2, you're doing the wrong thing. Okay? Alright. This is where you can type in piecewise functions. You could, or like, you're probably just used to typing like one function in, right? And so you might not know how to type in like 3 at a time for a piecewise. So here's the button that's going to help you do that. So if you're writing in your notes, you can say, go over here to below the delete button. I'll see delete. Below, there's like the little book, and then to the left of it, there's this button that has all like the squares and stuff on it. If you click on that, it's like a little template button. You've got like a fraction template, an absolute value, a bunch of stuff. Over here where mine's highlighted, it actually looks like a little piecewise. It has the little bracket and then the spaces. This one has 2 of them. This one has 3 pieces. You can actually, when you click on it, it'll ask you, I'll click on it and show you, it'll say how many function pieces. So you could actually do more than 3. You could do 4 or 5 if you wanted. How many do we have? So we're going to leave that, press OK. And notice your little template pops up here, and you are good to go to type it all in. So it takes some time to type it, but you'll see in a second that once you have it typed in there, it's very, very quick for you to evaluate it at any of these points, okay? So let's go ahead and start typing. In the first one, I've got 0.10x, and over here, I'm literally going to write the x values that work. So it says 0, anyone know where the less than or equal to sign is? You can call it out. Where do I find that if I don't know? Edlin, you see it? Good. Over here, control equals. you can type the less than or equal to x, control equals less than or equal to 7,285. All right, as quick as you can without making any mistakes, type the other two, and I will erase you.
Put a comma. You start right.
X. And those of you without your calculator are like, oh man, this is awkward, I don't have anything to do. I should probably bring it next time. Typing. Anyone done yet? Anyone faster than me? Haha.
I'm done.
Oh, she wins. I think I've done faster. Okay. And then press enter. Give you a few more seconds. You got 3 minutes. Thank you. I'll give you 10 seconds, and then wherever you're at, just watch. 4, 3, 2, 1. Okay, I'm gonna keep talking. Hopefully you're typing fast. When you press enter, it's going to graph it, and you might be able to see a lot of your graph. You might be able to see a little bit of your graph. It depends on your window, right? Of what part of the graph you're looking at. So we could adjust our window and see more. For the purpose of right now, we'll talk more about windows later. I want to talk about how you can, and you might have already done this before, now that we have something called F1, how we can use that to really quickly type in numbers and evaluate it, okay? So once you have it in there, if you toggle back to your calculator on your scratch pad, every time you type, if you typed it into F1, when you type F1, notice it went bold right there? That meant your calculator just said, aha, I know the F1 you're talking about is that piecewise function. And if you type 7,000, which is what we wanted, it's going to pop out 700. It knows exactly which of the pieces of your piecewise to go to. So look at the next problem. We're not done yet. Part B says now to find T of what?
10,000.
So instead of actually having to calculate it, you can just say F1 of 10,000. Boom. And you've got it right here, okay? The only additional thing that you'll have to do is possibly, like it says right here, explain its meaning. This is 700 puppies. What are we talking about? Dollars. Pause so I can get you out on time. Pause. Oh man, I just hit the thing. $700, which means when a person, thank you, as you're packing, you can look at me to tell me you're still with me. If your income is $7,000, your total tax will be $700, right? That's how you would explain and interpret what we just found, okay? All right, that's all you do. Type it in, evaluate things. Go ahead and on your way out, make sure you stack chairs for me for Miss Sanchez so we can make sure her room's all clean. And get started on those problem set problems tonight.